In my last video, we solved this linear programming problem using the graphing program Desmos. What I'd like to do now is to solve the same problem using Solver in Excel. So first of all, we're going to go to Excel and we're going to make sure that you know how to install Solver. So if you have a Mac, things are a little bit different, but I can show you how to set it up in a PC. So go to File, scroll down to Options, select Add-ins, and then down here Excel Add-ins, and then you want to make sure that your Solver add-in is checked. Once that's checked, then you can select OK, and you'll be able to find the Solver program here under the Data tab. Now, to set up and solve our problem, we're going to first set up our list of variables, and then we're going to have separate lines for each of our constraints. So our variables are the number of chairs and sofas. So in my Excel file, I'm going to have a spot for the number of chairs and a spot for the number of sofas. And this first row is just going to be the values of my variables. Now, I'm going to enter in some dummy values for these variables so that when I set up my equations, I can give a quick check as to whether or not they're working or not. You don't really have to have any values here. When you run Solver, it will put them in, but I find that it's easier to make sure that things are working properly by putting in some values. In addition to the chairs and sofas column, we're also going to have a column for totals. This is going to calculate the left-hand side of our inequalities and equations. We're going to have a spot to label the inequalities so it's easy for us to read the spreadsheet later. And then finally a column for the fixed bounds that each of the inequalities will have to satisfy. Now, each of the rows underneath the variables are going to represent the constraints that we are trying to solve for. So if we go back to our problem, we had three constraints. We had constraints that referred to carpentry, upholstery, and finishing. So these were our three constraints that we set up. When we put these problems into Excel for Solver, we're just going to treat it essentially like a matrix. We're going to enter the coefficient values into our table. So in Excel, I'm going to label my constraints, carpentry, upholstery, and finishing. And for my carpentry constraint, my coefficients are 5 for x and 3 for y. So 5 and 3. For upholstery, I had 2 and 7. 2 and 7. And for finishing, my coefficients were 1 and 1. And then down here, I'm going to have an equation for my profit. And so just like with my constraints, I'm going to enter just the coefficients that go with each one of the variables. So profit, we had 375 and 450. 375 and 450. Now, my constraints are all less than inequalities, so I'm going to enter those here. I need to be less than the indicated bounds for each one of the constraints. And then we're going to enter the bounds on each one of the constraints next. So I have 5,000 as my maximum for carpentry, 7,000 for upholstery, and 2,000 for finishing. And so we put in 5,000, 7,000, and 2,000. Now on this side of the equations, we want to calculate what the left side is doing given the particular values of our variables. When we put things into Solver, we generally want to say this cell less than this cell or this cell greater than this cell. We don't want to try to put formulas into Solver. It doesn't always like that. So on this side of the equation, what I need to do is I need to calculate the value of my variable times the coefficient plus the value of my variable times the coefficient. I can do this manually, or I can use a function like sum product, which is going to take the first input and multiply it by the corresponding second set of inputs, and then add the results together. Sum product, multiply, and then add. In order to make the copying go better, I'm going to put in my dollar signs next to my variables so that when I copy down the equation, the coefficients update, but the variable locations don't. And then I'm going to copy going down the column. And the same formula is going to work here for calculating the profit. And so if we go to formulas, we can see what all the formulas look like. So the coefficients updated, but the variables did not. So again, you can calculate these manually for small numbers of variables, but as your problems increase in complexity and you have more and more coefficients and more variables, sum product is a nice quick way of making these calculations. Okay, so now that we have the table set up, we're ready to go to Solver. So we're going to go to Data, and we're going to select Solver. Now the first thing we have to do is I have to identify the cell in which my profit or cost is being calculated. And so this one is in cell D8 right here. I have to determine whether I'm looking for a min or a max or trying to get a specific value. So in this case, I want to maximize profit, so I can leave this one the way it is. And then I want to indicate what cells correspond to the values of my variables. This is what Solver is going to update as it solves the problem in order to maximize this value. So we're going to highlight the two cells that correspond to the values of my variables. Finally, we have to enter the constraints. Now, all of my constraints are all less than inequalities, so I'm going to select Add. And I can enter them in one at a time. I can select this cell and then less than and then this constraint and then hit Add and do the next one. Or since they're all pointing in the same direction, I can highlight all of them. They're all less than, and then select all of the bounds. So this will, again, it'll use the left side of the equation corresponding to the right side of the equation, and it will match them up accordingly. So hit OK. Now, last time we mentioned there were non-negativity constraints. We didn't enter those specifically in our graph because we used the axes. These are built into Excel. You don't have to enter those specifically. And then we want to use the simplex method unless we have a really messy nonlinear equation or we're adding things like integer constraints. We still want to always start with the simplex solution method for linear problems. And then finally, once we're all set up, we're ready to hit solve. Now, there are various reports that can come out when Solver finds a solution. I'm going to select sensitivity. We want to keep the solution. If you restore original values, it just goes back to what it looked like before you solve the problem. And so we're going to hit OK. If you don't get an answer, if there's something wrong with the way you've set up the problem, then you're going to see it here. You'll get an error that says there's a feasibility problem or an infeasible solution. And that will tell you there's really no solution. Your inequalities can't all be satisfied at the same time. But here we are able to find a solution, and so we select OK. Now, in Excel, I can format these answers so that I can read them more easily. We can see that we've used all the upholstery and carpentry, but we're fairly far away from using all our finishing. We did run into a little bit of a problem, and this is the same problem we ran in with the graph, is that Solver doesn't know that we can't really sell partial chairs and sofas. It can only, so it's solved for this intersection value we remember from the graph, and that intersection happened to be a bunch of decimals. Now, when we did the graph, we just said, well, we'll just round things. But when we use Solver in Excel, we can actually tell it to find the maximum solution by adding one additional constraint, which is to make it an integer. So we can tell Solver, I want you to find a solution that is a whole number. So to do that, we go back to Data and go back into Solver, and we're going to add another constraint. We want these cells to be integers. We hit OK. Now, we won't be able to use simplex method anymore. We have to use the nonlinear. Now that it's near the solution, this is fine. If you're solving a problem and you know you want to add an integer constraint in, solve it without the integer constraint first, then add in the integer constraint afterwards. You won't be able to get things like the sensitivity report if you have an integer constraint, if you're using the nonlinear solver. And so there are certain features that just aren't available if you don't use simplex. And if you have a truly nonlinear program, if you're not near the solution, you may find a solution but not the best solution. So we want to, now that we've added our integer constraints, we can go ahead and hit solve. And so Excel will check to see if we can round some things up or some things down in order to get our best answer. And so here we were able to determine that we can actually do slightly better if we sell one additional chair and one fewer sofa, not merely rounding down, but one fewer sofa. So we get a slightly different value than we did when we did this graphically, but Solver was able to actually check all of the possible integer solutions nearby in order to determine what was actually the best and most optimal solution for us. And you can see now that we're not actually satisfying any of our constraints, but we're so close to our constraints that we can't actually add another product into the mix without going over any of these values. Now, the last thing that I want to mention, just for the sake of completeness, is I selected the sensitivity report. And this is, again, only available when you do the simplex method, but it gives us a little bit of information about, at the optimal solution, what are some information about how far I can change the bounds in order to improve my cost in a linear way, improve my profit in a linear way, how much, if I change the bounds by a little bit, how much my profit will go up, and important information like that that helps me interpret my solution if I wanted to make adjustments to my constraints. I would not bother adjusting my finishing bounds because I'm not satisfying them as it is. But I could adjust my carpentry and upholstery bounds because I'm actually satisfying them exactly. And by doing so, if I was able to get more carpentry or upholstery, then I could produce more chairs and make correspondingly more profit. And so this gives us a little bit of information about the problem and how we could extend the results. So it's a nice report to have if you have at least even a little bit of an idea about what the information is providing. So that's our solution.